Great. So, welcome everyone to day two of your HSMA training. Well done for, first of all, coming back. Hopefully we haven't put you all off. Today is going to be the start of 18 hours of training, hands-on training in how to program in Python. So on Thursday, we talked about first in the morning, we talked about what operational research is, what data science is, some of the things you may want to consider when you're undertaking a modeling or data science project, and also explored some potential applications and also some potential limitations and things you need to be aware of when you're doing modeling and data science projects. And then in the afternoon, we talked to you about the principles of programming. So we showed you some core concepts in programming, things like the idea of loops and functions and object-oriented programming, some key stuff that comes up in whenever you're learning any programming language. But that was all the theory, and today and for the next 3 weeks, we're going to be starting you on the practice of this. And this is really important because virtually all of the methods that we show you in terms of the modeling methods and the data science methods will use either Python or R. With only a couple of very minor exceptions. So it's really important that we, first of all, take the time that's needed to get you up to speed so you're comfortable in programming. I will say that Python is actually, once you get to grips with it, it's a very nice, friendly language, far friendlier than a lot of languages actually that are out there. So, and we're also going to be going through things quite slowly. So hopefully we've judged the pace okay, but we will gradually expose you to things, and you'll get plenty of opportunity to practice stuff as well as we go along. So there'll be lots of exercises where you try things out. Unlike on Thursday, a lot of the exercises we'll set today, although not all of them, will be individual exercises, so you'll try these things out yourself. However, that is not to say that you shouldn't be speaking on Slack within your support groups. Absolutely, you should do that. So just a reminder, if you're doing an exercise and you get stuck or you want to ask for some advice, message within your peer support group first, see if anybody can help. And if nobody can help, then somebody from that peer support group should post in the HSMA Support Hub channel on Slack and give the name of your group and say that you need some a mentor, and a mentor will drop along and scratch their heads for a bit. Probably won't know the answer either, but they will then Google it. I'm sure we will. I'm sure we'll know the answer. Great. Okay, so let's get cracking. So why are we teaching you Python? Primary reason, Python is now the most widely used programming language in the world, particularly over the last sort of 5 or 10 years. It's massively increased in popularity. It's actually pretty easy to use, and it has extensive libraries of code for common things we may want to do. So rather than reinventing the wheel every time that we write something, we're able to draw on what other people have done and pull that in. And that's a really powerful and useful feature of Python. And another really useful feature of Python, and the reasons that I first got introduced to Python when I was doing my PhD, and I was primarily introduced to it for this reason, because it allows us to get quick results and build and test iteratively. It's really good for building up experimental things. You can knock something up in Python really quickly and then see what happens. And it's got really nice features such as the interactive Python console, which allow you to interact with programs and variables, etc. So it's really good for that kind of thing, and you'll see more of that as the session moves on. So I'm going to duck out of this a moment because that's the old version of Spider, which I doubt any of you are using. So I'm just going to give you a quick overview of Spider. You'll hopefully have watched the video that Mike put out. So just as a reminder here, we've got 3 main sort of areas within the window. So Spider is what's called an IDE, an integrated development environment. It's basically where we can write programs, run those programs, interact with those programs. Spyder is by no means not the only IDE out there. There are lots and lots to choose from. And indeed, there are some that are arguably better than Spyder. But for consistency, a lot of us in the team certainly used to use Spyder, even if we don't now. And it's a good starter IDE. But you are very welcome to use your own IDE. But just be aware that during the course, we will be using Spyder predominantly. There are three main areas. This area over here is essentially where we write our script, our program. So remember from Thursday, we said that's the essentially a list of instructions that we want the computer to follow, and we package that up into what's known as a Python file, a .py file, and then Python will run through those instructions. It'll convert them into a language that is understood by the processor, and the CPU will then interpret and carry out those instructions. Over here, they might be in slightly different locations depending on how your thing is set up. You can move these around. Here we've got the interactive Python console, the IPython console. This basically allows us so this is where all of your outputs, any outputs we tell the program to make in terms of print statements, which we'll see in a moment, they'll appear here. But it also allows us to do things like we can run a program, and then once we've got a variable set up, we can do things with that variable. Or we can literally write Python statements within this console live, and it'll carry them out immediately. So over here, we're writing a program, and nothing will happen until we run that program. But over here, any statements we write, any instructions we tell it to do are carried out immediately, so we can immediately get it to carry out instructions, and that can be really useful when we're testing things. And then up here we've got this window now. A really nice feature of the latest version of Spyder is that it includes this little plots tab here. Yours will probably default to help, most of them do. Click plots, you won't see anything at the moment, but when we come on to talk about matplotlib, which is a package that allows us to generate graphs within Python, they'll actually appear here. And that's a really nice feature of that. And the other key one within here is the Variable Explorer. Again, there'll be nothing here at the moment, but remember we talked about variables on Thursday, and we said that variables are essentially boxes, and each box has a label, which is essentially the name of that box, which will describe in some way what information it contains, and then the value within that box, so within that variable, so the thing within that box that we're storing, those labels and values will appear in the Variable Explorer after we've run a program, or if we issue statements that involve variables within the interactive console. So it's a really nice feature that allows us to see what information is stored within our variables, and it's really handy for debugging when you come on to trying to work out why your program isn't working. And I can guarantee you every single one of you will run into that problem on a quite regular basis. You'll be able to see what's actually being stored in those variables. Very often that gives you a clue as to where your problem is. So we'll come on to more of that later, but just to as a sort of general starter overview, when we tell you to write programs for the exercises when you're using Spyder, this is where you'll do it in here. You'll write the program, and then we'll run it. Your outputs will appear here, and your variables and plots will appear up here. So there is, anybody who's done any programming before will be familiar with this. There's a tradition in computer science that the first computer program anyone should write in any programming language when they're first learning it is the Hello World program. And it's a tremendously exciting program. It basically tells the computer to put the words Hello World on the screen. Now, back when I was 4 years old in 1985, that was tremendously exciting, actually having my television screen say the words Hello World to me, and I told it to do that. I suspect it's slightly less exciting these days, but nonetheless, it is a tradition, and it is one we will uphold. And so let's first of all write a Hello World program in Python. And to do that, we need an instruction that tells Python to put something on the screen. And we have a function in Python called print. And remember, we talked about functions on Thursday. We said that functions essentially take 0 to many inputs and then output something. So in the case of the print function, we typically give it the thing we want to print in terms of text. So the print function will display some text on the screen, and whatever we pass into that function within the brackets will be the text that's actually printed. So let's look at an example. So if in our script window we were to put hello world, in fact, let's do that right now. So if I switch over to Spider, if I were to put in here print, oops, hello world, there we go. So I've written my program. It won't do anything because I'm over in this bit at the moment. I'm just going to push F5, or I can click on this green play button up here. Either will do. That will run the program. Push that over here. Wow, that's exciting, isn't it? We've got the computer to say hello world to us. That's pretty exciting, I think. So what it's done is it's run that program, which consists of a single instruction at this point, and that instruction is to print some text to the screen, and the text that we tell it to print is hello world. And we put this in inverted commas. You can also use single commas as well. That's also fine. They are pretty interchangeable within Python, so you can use either. But the convention typically for print statements in particular is to use inverted commas such as this. Okay, so that's the first program. We could also have used, just to demo this, we could use the console down here to do that immediately. So if I was to type print hello world down here, if I push enter, it'll immediately carry out that instruction. So over here, I've written a program and it doesn't do anything until I tell it to run, and then it'll do everything I've told it to. Over here, I write a single instruction, and as soon as I push enter, that instruction is immediately carried out. Okay, so that's the key difference there, and both of them are useful for different things.
Dan, just a quick one. You might want to pop your do not disturb on for your notifications as they're popping up at the top.
Yes, good point. Where's Slack? There it is. There we go. Fantastic. Thank you, Sean.
All good.
Okay, so that's our very first program. Now, you remember on Thursday we also talked about variables. As I said, we thought of them as boxes containing values. And in many programming languages, we create a variable by declaring it. And basically what that means is you specify the name of the variable that you want to create, the name of that box containing information. But we also specify the type. So you say this variable contains, is called name, and it's a string. It's going to contain some string information. However, in Python, variables are dynamic, which basically means we don't need to declare the type of a variable. It will automatically change the variable type depending on the first value that's passed into it. So if you set up a variable called name, and then you pass it a string in the inverted commas, a string of text, then it'll say, "Ah, right, name must be a string then." And similarly, if I was then to say name equals 52, for example, it would then change that to be an integer. So they are dynamic in the sense that they will change depending on what is fed into them. There are pros and cons of that, because some people will argue quite strongly that having a strongly typed language, that is, you have to formally declare what your variable type is, and you can't pass anything else in, is more rigorous. And they kind of have a point, but it's certainly inarguably easier to use in the Python format. So just to flag that up, that you don't have to declare what your what type of information your variable is going to store. Python will do that automatically depending on what you pass into it. So it's more of a just be aware of that thing. Here I've got the example of age equals 52. So that will store that as an integer. So age is now an integer variable. And down here, we've got name equals Bob with inverted commas. And so that will now store a string of text within the name variable. So let's remind ourselves, we covered a bit of this on Thursday. We talked about how variables have different types, like integers, and there's different string types and all sorts of different numbers. Let's remind ourselves of those and see how we use these within Python. So first of all, let's start with numbers. So one of the most common types of number variable you will use within Python is the integer, whole numbers. And that is what's known as an int. And an example here, so I've got my int equals 27. Now, another thing just worth flagging up here, you'll see an underscore between the words my int. So let's just dodge out to Spider here. So what you can't have, let's say we wanted to call my variable my number. If I was to type that and run it, I'll get an error saying invalid syntax. We can't have spaces in the names of things. So we have to do one of two things. We can either put an underscore between them, which is my preferred method these days for doing that. So the underscore essentially joins up that into one entity, and we can see where the spaces should be. Or you can use camel notation, which is where essentially the start of each new word beyond, except for the very first one, is capitalized. So you can do that. Now, I used to use the camel notation, but I think it's much harder to read, actually, especially if you've got anything that's a bit more complex. So it's entirely up to you which standard you go for. Certainly in my training, we'll be using the underscore notation. So if I run that, you'll see that runs without issue. So as well as integers, I've got, obviously life wouldn't be particularly interesting if we just had whole numbers. And whenever we're doing anything scientific, we're probably going to need floating point numbers. These are numbers with up to 15 decimal places.
Yeah, exactly.
Sorry, I've got somebody, Emily, on.
And these are the nurses who will support you because that's the thing, isn't it? The nurses, it's just they can't physically go to the wards.
Sorry, I'm going to have to mute you.
A lot of the guidance of the actual process, can't they?
Yeah, and that's what they do.
Yeah, cool.
Sorry, thank you. So we've got floating point numbers, and these are just numbers with decimal places, okay? And as you can imagine, these are very useful whenever we're doing anything meaningful. Specifically, floating point numbers are numbers with up to 15 decimal places. For the purposes of this and much what you'll be doing likely in your projects, that's probably all you'll need. There are other number types that allow you to have a greater precision. But as I say, for most of what you'll be doing at this stage, don't worry about that for the moment. So I may have, for example, my float, and that has a value of 32.451. Strings are the other big one that you'll be using all the time. Strings, if you remember from Thursday, are simply sequences of characters representing strings of text. And as I say, you can use either the double inverted commas or the single one. Tend to use double for these personally, but either is fine. And when you type this in Spider, you'll notice the color is green, slightly different to denote that you are typing in a string of text. So here I've got my str1 is Apple, and my str2 is Dan is the best teacher, which is clearly very true. So those are numbers and text, and those are the things you're going to be using a lot in everything that you do. But another really common thing that you'll be using is a list. And remember, we said on Thursday that lists are ordered sequences of items. So that is the order in which those items are stored in the list matters. So the fact that it's the second element in the list matters. and we'll come on to some different types of lists where that doesn't matter, and where it's unordered in a moment. But the most common one you'll use, and at least initially, is a list. We denote a list using the square brackets. So if I wanted to set up a list with these 5 items, the numbers 1, 5, and 3, followed by the string Matthew, and the Boolean, which you remember from Thursday, is a value that simply says true or false. Of true, then I would set up my list in this way. I'd set up my, whatever I want to call my list. So here I've just got it my list equals, and then the square brackets around the list of items. And that order is maintained. So my list is a sequence of items 1, 5, 3, Matthew, true, in that order. Okay, and that's important. So we've also got sets, which are similar to lists, except for 2 very fundamental differences. So sets are unordered. That is, it doesn't matter what order they're in. There is no particular order to the sequence of items. But crucially, they are unique items. You can't have the same value more than once in a set. Okay, and sets are denoted similarly to lists, except we use the squiggly brackets here, curly brackets. Okay, so if I wanted to set up a set called my set, and I wanted to put the values 4, 1, 3, 5, and 2 in it, or more commonly I might say 1, 2, 3, 4, and 5, then I would put them in here. And this is to demonstrate the order doesn't matter. So as far as the set's concerned, it's just storing these common values, but I can't have more than one of these values in here. We've also got things called dictionaries. Now, dictionaries you will use quite a bit as we go on. Dictionaries are essentially also unordered, so the order doesn't matter, but they are key value pairs. That is to say, we store a label for something and also the value represented, so the key and the value. So it's very database-like, and a lot of you will be familiar with the idea of databases. So I might have a dictionary, for example, that stores a value name, and corresponding to that is a string with a name in it, and a string called age as an index, and then a value associated with that. And the way we set up a dictionary is, again, using the curly brackets. But what we do is we set them up as key value pairs, such as we've got the key or the index value here, and then we separate it with a colon, and then followed by the value that we want to put in. And dictionaries at this stage, you may think, are they that useful? You will see lots of examples as we go through the training about why dictionaries are useful for certain instances. We've also got things called tuples. Now, tuples are ordered sequences of items, just like a list. However, they are immutable. That is, once you've created the tuple, it cannot be changed in any way. So a list, we can add things to the list, we can take things from the list, we can change values within the list. But a tuple, once we've set that tuple up, that's it. There's no changing it. You can't change any of the values within it. You can't remove any. You can't add any. That you're stuck with that tuple. And tuples are set up in exactly the same way as a list, except we use the normal parentheses rather than square brackets. And again, so you will likely, from these, probably be using lists and dictionaries the most. Sets and tuples tend to be used a little bit less. However, you will see, particularly for the natural language processing, for example, that the way you add to the training of the package we use has to be set up as a tuple, and you'll see how we need to use the tuple format in order to do that. And then lastly, as we said, we've got booleans, which are just values of either true or false, which are enormously useful when we come to do programming. And we simply use the words true or false. They are not in inverted commas because that would be a string. So it literally is just the word true or false, and it must be capitalized. The first letter must be capitalized. So exactly as you see here, true or false, written in that way. Okay, so now we've learned a bit about that. Let's amend our Hello World program so that rather than just saying hello world, I want it to say hello to me. So if I go back to Spider here, So I'm just going to turn off notifications on both Slack channels. No, where are we? Okay. Sorry, I'll remember to do this next time. Right, so let's go over to Spider. So let's change the Hello World program. So this time, instead of saying Hello World, I want it to say hello, whatever my name is. So I'm going to call my variable storing my name, and then I'm going to say equals. Now the equals operator doesn't mean equal, as in our two values equal, and we'll come on to the difference when you want to say that in a moment. It equals is the assignment operator. So it says this variable name here, into that, I want you to assign this value, stuff this value into that box, okay? So here, I'm going to say, my name is Dan. So now, rather than saying hello world, I can say print hello, and then I can come out of this text string here, and I can put a comma, and then what I can say is I can give the variable name that I've used up above. So if I run that, you'll see it says hello Dan. Now, what it's doing there is essentially it's saying print this string of text, which I've hard coded, and then the comma separates the more than one input into a function. And then I want you to print whatever value is stored in the my name variable. So Python will then go to my name, open the box, see it contains the string Dan, and then it will print that. And so when I run that, you can see it says hello Dan. Even more exciting. You will also notice, however, that it's put in a double space here. By default, what Python will do, each element that you pass it here, it will automatically put a space in. Now, it's personal preference, but I don't like that. I prefer to space things out in the way that I can see it on the screen. So here, I want a space after hello. I could have done, if I'd have just taken that space out and run that, it would have come up correctly down here, hello Dan. But I don't like doing that. And so if you're like me, and I know there's others out there, what we can do is we can write things with the spaces however we want. And then all we need to do is add a little extra input at the end of our print statement called sep, which stands for separator, equals, and then open and close our inverted commas. And that basically means don't put in any separators between the elements that you're printing. So if I run that now, you'll see it's correctly printing hello Dan with the spaces. So it prints this string of text exactly with the space, but then it doesn't add a space before it then prints the string of text Dan. Again, it's personal preference, but just make sure you're consistent in how you use that. Okay. Now, as well as printing things out to the screen, we very often need to get input in from the user. We need the user, we just ask the user something in order to continue the program. And fortunately, unlike other languages that should go unnamed, Java, getting input from a user in Python is extremely easy. Okay, so we simply tell Python that we need an input. We give it any message that we want to display to the user, a bit like a print statement. And we give it the name of the variable in which we want to store the input. Because once the user inputs something, types something in and pushes enter, we then need to store that value somewhere. And so we need to give it the name of the box, the name of the variable in which to stuff that value. Okay, so let's look at an example. Let's say I want to ask the user how old they are. I could use this statement. Age equals input, as we use the input function here, and then the input to the input function is the string of text that we want Python to print out, to display to the user, to prompt them to input something. So let's just try that out. So if I type in age equals input, how old are you? Question mark. If I now run that, you'll see Python pops up down here in the console, how old are you? But it hasn't finished running. The program is still running. So down here, I can type in 39. So now you'll see up here in the Variable Explorer, in age, it's got the variable that we've called age, and it's got a value 39. So if I was to run that again and put 72, you'll see that's changed up here. So you can see how the Variable Explorer is really useful in allowing us to keep track. Now, I will say the Variable Explorer will only update when the program has finished running. So you won't be able to view live changes whilst the program is running. But it's really useful to see what has been stored in various variables. Now, as I say, we can do it like this. There might be a particular issue, for example, if I was doing exactly this, asking the user to input an age. Does anybody know what the problem might be? If I was just to do this exactly as I've got it on the screen, can anybody think what if there might be any potential issue with this?
Is it stored as a string?
Exactly so. So whenever Python is asked to ask the user for some input, anything that is typed in is taken as a string of text, because they can type anything. So we can't, of course, if we store that as a string of text, we can't then play around with it if we need it as a number. So if I go back to Spider, you'll see age stored as 72 here, but you'll see type is listed as a str string. Okay, so it's not stored that as a number. We want that as a number. So to do this, what we need to do is something called casting. And casting basically is just a very fancy way of saying turn one variable type into another, like magic. So basically, we can say cast this string, turn it into a number. Now, obviously, if you try and cast the word hello, it won't be able to do that and it'll throw up an error. But Python will be able to intelligently see that there's a number there, and we'll be able to say, okay, I'll store that as an integer, for example. So I can do that in one of two ways. I can either do that as two separate instructions. So I can do exactly how I did before, age equals input, how old are you? And then I can say age now equals, so I'm going to overwrite the value of age with this, where I say int, that's the type of variable I want to turn it into. And then the input I give to int is the name of the variable that I want to cast. So in this case, age. So what that'll do is I'll say take the value of age and cast it as an integer, make it a number. So that's one way. And you may prefer to do that as you're first starting out, or you could do it all on one line. So you can say, I know that I'm going to need this as an integer, so I'm just going to do this all in one go. So I've got my input statement here, but in brackets, wrapped around that, I'm going to put the integer. So I want, what Python will see here is I've got a variable called age. Within that, I'm going to store an integer casted value. And the value I need to cast as an integer is this. It's whatever the user inputs. Okay, so you're essentially nesting this statement within this statement. Be careful about nesting too far. You can get statements that nest within nest within nest, and it can get very complex. So it's not generally advisable for anything beyond relatively simple things, but particularly for inputs where you're going to need to just cast it in, usually as an integer or as a floating point number, for example. Then this is typically what we would do, but it's equally fine to break it out. And that talks to another thing you may want to consider whenever you're doing any programming. When you're first starting out, don't be afraid to take the long-winded approach of breaking everything down. That's absolutely fine, and it can really help you think things through. And there's nothing wrong with that. That's absolutely fine as a way of writing this. This is just a convenient shortcut. Okay, I've talked for long enough. So I want to set your first exercise. So I want you to turn to Spider, and I'm going to give you 5-10 minutes just to do exactly this. Use what you've learned so far. I want you to write a program that asks for the user's name, then asks for their age, and then prints the message, happy birthday, whatever their name is, you are, whatever their age is today. Okay, So I'll give you, let's give you till quarter past 10, and then we'll come back on here. So have a go at that. If you get stuck, remember, post in your peer support group first and ask if anybody can help there. And if not, if nobody can help, then post in the HSMA Support Hub channel asking for a mentor. Do make sure you say which group you're from, because we haven't got that memorized, unfortunately, and we'll be along to help. So have a go at that, and if you've got some spare time, have a play around with it. We will see you shortly. In fact, let's keep this running. It's only a 10-minute exercise. Actually, no, I'll muck up the recording. So I will disconnect from this now and then rejoin at quarter past. Okay, any questions about any of that? No, great, fantastic. If you get stuck, give us a shout. Otherwise, see you in 7 or so minutes.